In this chapter, we've been talking about computing arithmetic expressions. Some of the expressions have worked with the same data type, such as multiplying or dividing or adding two integers. Some of them have been mixing data types. And that's a common procedure in C++ to have an expression with multiple data types. Here's an example. We have the constant double pi, and we have the integer 3, which is a literal in this case. When we multiply them together, we get the result 9.42478, which is a floating point number. And that's exactly what you expect to get. Sometimes, though, with arithmetic operations, the data types cause results you don't expect. Take a look at this example. Here we're simply dividing 3 by 2. We expect the answer to be 1.5, but watch what happens when we build and run. The answer is 1. So you say the compiler made a mistake. Well, once again, I'll say the compiler never makes a mistake. What happened was we tried to divide two integer values, and the result of two integer values will always be an integer result. So it couldn't display 1.5, it could only display the integer part of that, which is 1. To get the answer we want, we need to make one part of that expression floating point. So we make the denominator 2.0. Now when we build and run, we get the result 1.5, which is what we expect. Let's look at some more examples of working with data types and arithmetic expressions. Let me finish commenting out our old results. I'm going to create two variables, an integer variable number and a double variable rate. I'm going to assign an integer value to number and a floating point value to rate. Unlike in other languages, it's certainly okay in C++ to assign a value of one data type to a variable of a different data type. So for example, in this statement, I've assigned the value rate to the variable number. When I display the value stored in number, let's build and run, we see we get the value 1 instead of 1.0345. Why is that? Well, it's because I tried to store a floating point number in an integer variable. When that happens, the compiler performs something called a narrowing conversion. We don't have to tell it to do it, it does it automatically or implicitly. A narrowing conversion simply means that we're narrowing the value that we've assigned to a variable due to the fact that we've gone from a floating point data value to an integer data type. Let's look at another example. This time we're going to take the integer value 2 and assign it to the double variable rate. We won't see the result of this when we display it because the C++ compiler displays whole double values without the 0.0. But nonetheless, the value that is stored in rate in this example is 2.0. That is something called a widening conversion. In a widening conversion, we actually make the data type wider from 2 to 2.0. Both of these are examples of, and I mentioned this earlier, of what are called implicit conversions. There's also such a thing as an explicit conversion using something called a typecast. A typecast allows us to actually tell the compiler we want the conversion to go from one data type to another. So for example, in the example earlier, I could have written number, assign the value, and then in parentheses int. That's the typecast. That's saying take the value that follows, rate, and cast it or convert it into an integer value. Just like we could have done the same for number. Here we're saying typecast number as a double and then assign it to the variable rate. Typecasts are always preferred over implicit conversions because you're making your intention clear to the person reading your program. And I'll say again, it's just as important for your programs to be readable by people as it is to be executable by the computer. We'll wrap up this chapter with an exercise on converting formulas to C++ code.